We're going on a deep dive today into a concept so fundamental, so seemingly simple, that it's kind of resisted definition for over 2,000 years. The geometric point.
Right, that little dot.
Yeah, exactly. Since, ancient Greek geometry, think Euclid, the point's basically been defined as a pure abstraction. That which has no part. Zero size, zero mass.
Zero dimension, just a location.
A placeholder, really.
Yeah.
But this assumption, this idea of the ultimate zero, turns out to be, well, the precise reason our equations for reality have been failing. Kind of spectacularly, actually.
That really is the crux of it. That zero-size point assumption, it sort of infected modern physics with what we call the infinite divergence problem.
Okay.
So when physicists tried to calculate properties of fundamental particles, things like, say, the electron's own self-energy, the math didn't give a neat finite number, it just exploded.
Exploded.
Yeah, the value went straight up to infinity.
So the universe was essentially telling physicists, hang on, you're dividing by zero here.
That's a great way to put it.
Yeah.
And for decades, the workaround was this process called renormalization. It's incredibly clever mathematically, but deeply unsatisfying,
Hey, can you give us maybe not the super technical, but the core idea, not just the ramen analogy?
Okay, sure. Renormalization is essentially a way to subtract one infinity from another infinity, carefully, to get a finite, measurable number that actually matches experiments. We use it all the time in quantum field theory. It works.
But our sources called it a stopgap, a trick.
Exactly. Like the salty ramen analogy you mentioned, you add water, it tastes okay, but the salt's still in there. You haven't fixed the core issue. Renormalization dealt with the symptom, the infinite values, but it never tackled the underlying disease. The assumption that the point was non-physical, just zero.
Right. Okay, but now we have this, revolt of the point. A totally new theory emerging from, 35 years of pretty much solitary research in South Korea? This K-Science initiative?
That's the story, yeah. A major moment for them.
And it claims the geometric point isn't an abstraction at all. It's real, physical.
That's the core declaration.
Okay, let's unpack this then. What is this revolutionary new definition? How big is this shift?
Well, the point is now officially declared a real entity. It has a minimum, actual, measurable size, mass, and time. It's the fundamental unit, the sort of bedrock supporting the universe's order.
A seed.
Yeah, the sources sometimes call it a pseudo-black hole, like a super condensed seed of physical information.
Okay, and what makes this completely unprecedented, I think, is that they didn't just say this. They apparently calculated the actual values using this specific theory and a powerful AI.
They did, and the numbers they're staggering.
You really need to remember these numbers, people listening, because they basically redefine reality as we know it. What's the size?
Okay, the calculated finite length, or size, of this fundamental point is approximately 1.977 times 1095 meters.
Minus 95. Wow.
And its mass is calculated at roughly 4.108 times 1034 kilograms.
Minus 134.
And the time, the sort of minimum tick of its existence, is about 6.595 times 10^104 seconds.
Okay, those numbers, they look like zero, practically. I mean, how is that different?
That's the critical thing. They look like zero, but they're not. That's the razor's edge between an abstract mathematical idea and actual physical reality.
I'm struggling to even picture 1095 meters. How do we get a handle on that scale? How does it compare to what we thought was the smallest?
Right, so for context, we usually talk about the Planck scale. For decades, the Planck length that's around 1035 meters was seen as the absolute limit, the smallest meaningful length.
The edge of measurable reality, basically.
Pretty much. The idea was if you tried to look at anything smaller, the energy involved would just collapse space-time into a tiny black hole. Physics breaks down.
Okay, so Planck length is 1035 now. This new point is 1095 Sievert.
Exactly. That means this fundamental point is over 60 orders of magnitude smaller than the Planck length.
60 orders. It's hard to grasp.
Okay, try this. Imagine the size of a single atom compared to the size of the entire visible universe. That's a vast difference.
Yeah, huge. Almost incomprehensible.
Right. The difference in scale between the Planck length and this new finite point is greater than the difference between that single atom and the whole universe.
Okay, that helps. It's moving from effectively zero to incredibly tiny, but real.
Precisely. Infinitely small, but demonstrably real. And there's a philosophical angle here, too.
Ah, the Jisumune.
Yeah, exactly. The researchers connect it to these Eastern concepts. Jisamuna means no smaller thing within the smallest. This point is that smallest thing. And Jidemwe, no greater thing outside the greatest. That's the universe.
So the smallest point is fundamentally linked to the largest possible scale, the cosmos.
That's the idea. This physical finite point connects the absolute minimum structure to the maximum extent of everything.
The numbers themselves are mind-bending. But figuring them out, that needed some equally radical tools and theories. Which brings us to section 2. How on earth did they calculate numbers 60 orders of magnitude smaller than anything we can currently measure?
Yeah, how do you measure that? Well, you don't directly. It comes from the theory. The theoretical engine here is called OPS, the one-parameter solution.
One-parameter solution, okay.
The driving belief behind OPS is that the universe isn't governed by a whole bunch of separate arbitrary laws and constants. Instead, it all converges back to a single underlying structural parameter.
So things like the speed of light, electron mass, gravity, they're not independent numbers someone just dialed in. OPS says they're all related, like notes in a musical chord.
That's a perfect analogy. Yes, structurally related. And to prove this, or rather to find this relationship, they use something called the Buckingham-Tapital theorem. It's a tool from dimensional analysis.
Dimensional analysis, making things dimensionless.
Exactly. This is key. The theorem lets you take physical variables like mass, length, time, charge, and combine them into dimensionless numbers, pure ratios.
Why is that so important?
Because dimensionless numbers are universal. They don't depend on human choices like meters or kilograms or seconds. They represent the inherent mathematical relationships in nature itself, free from our arbitrary units.
Okay, but you're talking about finding the single pattern connecting, 18 fundamental particles, 5 force carriers, all expressed as these dimensionless ratios interacting? That sounds computationally insane for a human.
Oh, it is absolutely impossible for a human or even a team of humans. That's where the AI comes in. They developed the AI Buckingham machine.
Right.
This AI crunched over 900 million data points. That's about a terabyte of structural data derived from these particles and constants. No human could map that complexity.
And the AI's job was to find the music, find the single harmony.
Harmony, exactly. The single pattern that governs how the masses of these 18 fundamental particles relate to each other and their interactions.
Now, hang on. I read in the source material that to make this pattern work, they had to make a pretty big change to the standard model of particle physics. They swapped out the gluon,
the strong force carrier,
and put in the graviton, the hypothetical gravity particle. That sounds less like finding a pattern and more like forcing one. Isn't that a major leap, potentially controversial?
It's a huge point and absolutely critical. The argument from the OPS perspective is that the existing standard model, when you treat its constants as independent, is the arbitrary setup. They argue that only by incorporating the graviton, the missing piece needed for quantum gravity, could the AI find the single, truly unified, non-arbitrary structure.
So the AI couldn't find one single pattern without the graviton?
Apparently not. The AI analysis showed that without the graviton's mathematical properties included in the mix, the dimensionless numbers didn't resolve into one unified structure. They stayed fragmented. Including the graviton was necessary, they claim, to reveal the underlying correct harmonic chord.
Okay, so the AI didn't just process data, it acted like a detector for the most fundamental mathematical consistency. And that consistency required the graviton. And that revealed the superconnection.
Yes. And that connection is the really big prize here. The AI demonstrated mathematically within this OPS framework that the fine structure constant alpha, governing electromagnetism, the small stuff,
Microscopic world,
is directly linked to the cosmological constant lambda, the thing driving the universe's expansion, the big stuff.
Macroscopic world.
And the bridge connecting them, it's mediated entirely through the calculated properties, the size, mass, time of this newly defined finite point.
Wow, okay, if that link holds up, that changes everything. Which leads us straight to the payoff. These huge problems in physics, the grand challenges, or non-J, as the sources call them, that a non-zero point supposedly solves.
Right. The first one is the big one, the holy grail, you could say. Unifying quantum mechanics, QM, and general relativity, GR.
The two pillars of modern physics that just don't talk to each other properly.
Exactly. They've been at odds for a century. QM is all about discontinuity. Reality comes in little packets, quanta. It's lumpy. GR is about continuity. Space-time is smooth, a geometric fabric. They fundamentally clash, especially in extreme places like black holes or the Big Bang.
So how does a tiny but not zero point fix that?
Because the finite point, as defined in this theory, is both. It's inherently dual. It's a discontinuous, indivisible unit like a particle, a seed, but it's also the fundamental basis from which continuous geometry and mathematical sequences emerge.
So it has the properties of both lumpiness and smoothness built in.
Precisely. It embodies the duality needed to act as a bridge. It allows QM's quantum jumps and GR's smooth curves to coexist, making a coherent theory of quantum gravity finally seem possible.
And that immediately takes care of those infinities we started with, right?
It does. That's challenge 2, eliminating singularities. Our current physics predicts singularities, points of zero size and infinite density at the center of black holes and at the very beginning of the Big Bang.
Which is basically where the equations break down. Physics throws up its hands.
It's mathematical fantasy land, yeah. But if the point has a finite size, even an incredibly tiny 1095 meters, then density can never become infinite. There's a maximum possible density, the density of the point itself.
So no more infinite collapse.
No more infinite collapse.
Yeah.
The theory redefines these extreme points not as singularities, but as pseudo-black holes, points of maximum but finite condensation of information and energy. Reality doesn't break down.
Okay. And the third one, the one often called the biggest blunder in physics history.
Right, challenge 3. The cosmological constant problem. This is that embarrassing discrepancy where quantum mechanics predicts the energy of empty space, the vacuum energy, or lambda should be enormous, like 120 times larger than the tiny amount we actually observe driving the universe's accelerated expansion.
120 orders of magnitude off. That's not good.
It's famously called the worst prediction in the history of physics. But the resolution, according to this theory, is baked right into the OPS structure and the finite point.
How?
The calculated, incredibly small mass and the finite density of this fundamental point provide the correct physical scale needed for the vacuum energy calculation. When you replace the assumption of a zero-size point with the actual calculated size of 1095 meters, the whole calculation changes. That enormous 10 factor naturally cancels out, or rather, resolves correctly.
So the structure of the very smallest thing fixes the measurement of the universe's largest scale behavior.
That's the claim. The scale was wrong because our fundamental unit was assumed to be zero, an impossibility.
Before we dive into the philosophy, we really have to acknowledge the human story here. This wasn't some massive, well-funded international project. This was, as you said, 35 years of one researcher essentially working alone. That level of dedication is something else.
It really is. It speaks volumes about conviction. Imagine the sheer confidence or maybe faith required to challenge not just current physics, but Euclid himself, the Planck limit, and to stick with it for decades.
Pouring your life into these seemingly impossible numbers.
Yeah. You can see why the sources frame it as a potential turning point for South Korea in science, moving from, being a fast follower in technology to potentially setting fundamental rules. K-science establishing foundational knowledge.
It's a powerful narrative.
Yeah.
Okay, now, let's shift gears slightly. The philosophical implications. If the universe's smallest building block is simultaneously a discrete unit and the source of continuity, how does that change how we see, well, everything?
It forces us to reconcile things we often see as opposites. Take continuous versus discontinuous. We live with this duality all the time without thinking about it.
Like the film analogy.
Exactly. The sources use great examples. A movie looks like smooth, continuous motion, right?
Right.
But it's actually just 24 discrete, separate still frames shown every second.
Right, discontinuous creating continuous.
Or digital music. It's made of thousands of discrete digital samples per second, but what we hear is a smooth, continuous melody. The finite point is like that frame, that sample, the fundamental discontinuous unit that generates the continuous reality we experience.
Okay, I see that. And what about bigger concepts? Like creation versus evolution?
That's another fascinating application in the source. Creation, in this view, isn't necessarily opposed to evolution. Creation is the instantaneous, discontinuous act, the laying down of the first point, the first fundamental unit, the striking of the first note.
The beginning.
The beginning. And evolution is the continuous process that unfolds from that beginning, the building of the structure on that cornerstone, the development of the melody from that first note.
So they're not enemies. They're two aspects of the same reality, unified by this dual nature of the point. One initiates, the other unfolds.
That's the synthesis offered, yeah. The ultimate beginning and the ongoing process, linked by the structure of the smallest thing imaginable.
That really does tie things together in a profound way.
So if we try to connect this to the really big picture, discovering that the point, the absolute foundation of geometry itself, is actually a physical, finite entity, it means we have to rewrite the basics. Geometry, physics, maybe even philosophy, all at once.
It's aiming for a single language.
The first truly unified language, potentially, for science, philosophy, maybe even touching on theology, depending on how you interpret creation.
Okay, so bring it back to you, the listener. What does all this mean for you right now? Well, it means you're now aware that the smallest thing you can possibly conceive of isn't just nothingness, isn't zero. It's a real, measurable entity that holds the key, potentially, to unlocking the universe's biggest mysteries, from the tiny electron to the vast expansion of the cosmos.
And the research hints at something maybe even deeper. It suggests that our own minds, especially our intuition, might be somehow fundamentally connected to the inherent order within this point structure, like a mirror reflecting. Well, the source says God's order, but let's say the fundamental order.
A mirror reflecting the base code of reality.
Something like that. So if this tiny finite point holds the secrets of the universe, if it's the minimum unit required for existence, what does that imply about the power of the smallest things in our own lives? The smallest idea you have, the smallest choice you make.
It might be the minimum input needed for the maximum possible change.
Maybe. It suggests that the infinitesimal isn't powerless. It might just be the most powerful thing there is. Something to think about.